Okay, so in this video, we're going to be talking about lesson 9.2. Just as a reminder for fifth and seventh hour students, you're going to be watching this with the sub today. We're doing things a little bit out of order. We haven't actually done our practice day on 9.1 yet, but we will do that tomorrow, and you'll have tomorrow and Thursday to do those practice assignments and the CFUs. So right now, we filled out page 2 and 3. We're skipping over page 4 and 5 right now, and I think we're on page 6 at this point. So go ahead and find page 6. If you don't have a packet from yesterday, the sub should have the stack of packets. One should be in there with your name on it if you were gone yesterday. So here we go. The top of this page, I want you to start off trying to see what you can remember on your own, especially this top section. This is from the last quiz. We're going to have the sub pause the video for probably 5 minutes and do these two sections to see what you can remember. For this second section, look back in your notes from yesterday and see what you can remember about the quadratic function. Okay, so assuming that you've gone over this already, you've tried this yourself first, let's go ahead and go over this. So we are looking at just a few reminders of working with variables. X plus x, that's 2x. When we add the variables together, we're combining like terms 1x and 1x makes 2x. When we're multiplying the variables, 1x times 1x is still 1, but then the x to the first times x to the first is x squared. And so we don't really write the 1x in front of that, but x times x is x squared. You're going to see that one coming up a lot. When we do something like x times negative 3, we're just going to write it as negative 3x. That does mean negative 3 times x. That's just how we write it. X times 5, we're going to write as 5x. So we can just see some little reminders there of what we're doing. Then we're going to go ahead and distribute. We've got the blanks here. You saw on the test, we didn't actually give you those blanks on the test, but just to remind you here, we're taking x times x as our first distributing. That is x squared. Then we're taking x times negative 4, and we'll write that as negative 4x. And the question down here, is this expression quadratic? Yes, because it's got an x squared term in it. Next, we got FOIL. So remember, we're doing our firsts. X times x is x squared. X times 2 is a positive 2x. 3 times x is a positive 3x. See if my computer will do it. And then 3 times 2 is a positive 6. Sorry, my computer's being a little laggy right now. That didn't work. There we go. So that's a 3. And then we have to remember to combine our like terms in the middle. So x squared, we've got 5x in the middle plus 5x, and then a plus 6. Make sure you got those plus signs. This is not 3 separate things. Is one big expression, and this is a quadratic expression, yes. So you can see the distributing and the FOIL we did last chapter is really important because it's going to be how we get quadratic functions, or quadratic equations at this point, I guess. Last thing here, quadratic functions, just a reminder from yesterday. Hopefully you looked back and saw we've got y equals ax squared, plus bx plus c, there we go. And in an example like this where it's just y equals x squared, a is the number in front of the x, which in this case we don't write the 1. B is the number in front of the x term. Well, there is no x term, so there's 0 x's. Whoa. Oh, man. Laggy computer. 0. And then C, there is no plus 5 or minus 6 or whatever, so that's just 0 as well. So B and C can both be 0, and either one or both can be 0. And A can be 1, and A will be 1 a lot. We're going to deal with a lot of times in this chapter where A is 1. Second chunk here, 2 possible shapes of a quadratic function, an up-up parabola. Looks like that. You can do a better job than my laggy computer can. A down-down is going to look like that. And I already said the word, but a quadratic function, the shape of the graph is a parabola. You can practice saying that word parabola. We don't want to be in a math class saying parabola or parabola. It's parabola. So we're going to practice saying that because we have to be able to speak that math language. Okay, so today we're going to be talking about all the different properties of parabolas. And so there's a lot of things, hopefully, that you've noticed about these so far. There's U-shaped graphs. We've talked about the idea that these are symmetric. And so, yeah, we're going to have a few things going on here. So over on the gray side, it says draw a vertical dotted line. So I'm going to do, I do more of a dashed line, but it doesn't matter, dotted or dashed. Plot a point towards the bottom of the axis of symmetry. This thing is going to be called the axis of symmetry. Label that point V. So I'm going to put a point there. I'm going to label it V. And then draw a parabola that goes up from the vertex. And so something that we've noticed about parabolas, they always have like a lowest point or a highest point, and they're symmetric. They look the same on the left and the right. You've noticed even with some of the points, like we've had the point 2,5 and then negative 2,5. So you can see you've got that symmetric thing going. So this point here, this vertex is, this point that we labeled V is called the vertex. This dashed line right here is what we would call the axis of symmetry. And then the parabola itself looks like that. So at this point, axis of symmetry, we are going to abbreviate it A, if I can write here, AOS, axis of symmetry. So I don't have to write those whole words out. This is the imaginary line that you could fold a parabola along. So if you imagine, oh my gosh, gotta let my computer think for a second. Oh man, it is struggling today. So if you imagine folding your parabola, so that the two sides, left and right side, meet up. So if you were to take your parabola and fold it in half so that the left and the right side matched, that's the axis of symmetry. That's that dashed line down the middle. Every single point on your axis of symmetry is the same distance from both sides. So if I counted over 3 boxes there, well, it would also be 3 boxes there. What you might notice about our axis of symmetry is it's a vertical line, which means it's always going to be an x equals equation. So x equals a number. And then the vertex is going to be either the lowest or highest point lowest or highest point. So where the graph kind of turns around, where it goes from going up to going down, or going down to going up. All right. And at that vertex, we would say that a graph is either going to have a minimum point. So if the graph goes up, you're going to see that we've got a minimum point, a lowest point. And if our graph goes down, then we are going to have a maximum point. We'll call those the min and the max. Minimum and maximum. So we've got a few key points there. You'll see those abbreviated. Min and max, you'll see them written out. But the minimum and maximum points are the vertex of the parabola. Just depends on if it goes up, then it's going to have a lowest point, so a minimum. If it goes down, it's going to have a highest point, so a maximum. Okay, so you're going to see basically 2 types of questions here. The first one is going to give you the picture of the graph and ask you a bunch of questions about it. So let's do a couple of those first. First thing it says is draw the axis of symmetry with a dotted line or dashed line. We just need to know that it goes right through the middle, right through the vertex, like this. Then it's going to ask you what's the equation. It's always an x equals equation because it's a vertical line, and it goes through the x-intercept there is 1. So I'm going to have x equals 1. Every single point along that line has an x-coordinate of 1. The vertex. It's asking us for the coordinates of that vertex. So right there, that is the point 1, 0. It says, what is the x-intercept? So the x-intercept, just like with a line, is where it crosses the x-axis. Here, that is the same as the vertex. It won't always be, but in this case, it is. It's that point right there. That's the x-intercept. What is the y-intercept? That is where it crosses the y-axis. So we have that point 0, 1. And then does it have a maximum or a minimum? So if I look at this point, the vertex is currently the lowest point on the graph, so it is a minimum. All we're going to be doing is asking there, basically, is the vertex the maximum point or is the vertex the minimum point? Okay, on the second one, go ahead and take, let's say, 2 minutes. Pause the video for 2 minutes, try this one out, and then I'll do it. You can check how you're doing. Okay, welcome back. So, drawing the axis of symmetry is going to look like that. The equation of the axis of symmetry, since it goes through -3, is going to be x equals -3. My vertex, I'm going to put a dot on there. That is the point -3, 4. You will notice here the axis of symmetry and the vertex, the x-coordinate of the vertex is on the axis of symmetry. How many x-intercepts are there? How many times does it cross the x-axis? Well, here it crosses the x-axis twice. At the point -5, 0, and at the point -1, 0. It doesn't actually ask us to name those points, but it's a good habit to be in. We're going to do it a lot. And then the y-intercept, where it crosses the y-axis, is right there at 0, -5. Our last question, does it have a minimum or a maximum? So I'm looking at this vertex point, and this is the highest point my graph ever gets to. So that is a maximum. Okay, so you're going to have a bunch of questions about that. Second one here, our second type of graph is going to be taking that information and drawing it on the graph. We're putting this in the order it's in, so you can do it in order. Make sure that you're doing this in order. So the axis of symmetry is x equals 4. We're going to draw our axis of symmetry, and we know it's a vertical line, and since it's x equals 4, it goes through 4. Draw it as a dashed line or dotted line, something like that. It says there are no x-intercepts, so we'll keep that in mind. There's no place on this x-axis where it crosses. None. The vertex is located at 4, 2. So I'll plot that. At this point, I want to think about the fact that if there's no x-intercepts, and that's my vertex, it's probably an up. Well, it's got to be an up, up, because if it went down, down, it would cross the x-axis. Okay, there is a point, 2, 3 on the parabola. 2, 3 is on the parabola. 6, 3 is on the parabola. You can see there, those are symmetric about my axis of symmetry. They're the same distance, 2 units away, 2 units away. The y-intercept is 6. So on my y-axis, I'm going to plot the point at 6. One of the things we're going to want you to do very often here is use the symmetry. If I know that this point, I can count the boxes, 1, 2, 3, 4. Well, I have to go 1, 2, 3, 4 this way, and there's going to be another point. So any point we can plot on the left, we can flip over and plot on the right. And it says there is a minimum point, which looking at our graph, that we knew was true already. So we're going to go ahead and put our shape in there. Make sure, yes, that is a minimum point. That makes sense. That's our graph. So they're going to give you different information. They might tell you the axis of symmetry and the x-intercepts and the y-intercept, and not give you 2 other points on the graph. Each one's going to be a little bit different, but go in order. If it tells you a point, like the vertex or the y-intercept, plot that point. Use the axis of symmetry to mirror your graph left to right. Count the boxes and then count the same on the other side and graph those. So what I want you to do right now would be, with whatever time is left, do your best to finish up yesterday's proficiency practice and CFU. So if you've got we did page 2 and 3 in the notes yesterday, so page 4 and 5 in your proficiency practice, and then the CFU that's on Canvas. That's what I want you to focus on today. That way at the beginning of class tomorrow, we can start with some questions on that, and then roll into doing our proficiency practice for this one. You will have tomorrow and Thursday to work on this, but I'm only going to be here tomorrow. I'm only going to be here Wednesday. So we got to make sure we use that time effectively and get our questions answered, because I want to make sure I can help you out as much as possible. So thanks for listening. Hopefully you got some good notes, and I'll make sure this is also posted on the Canvas page if you need it.